706. In this class, we are going to learn various aspects of wall formwork. In the last two lectures, if you remember, we have covered foundation formwork. We discussed various types of conventional foundation formwork. We discussed proprietary or patented foundation formwork, and we also discussed some design issues pertaining to foundation formwork. We will follow the similar sequence in this lecture also, but we will be focusing our attention on wall formwork. So, I have just made some outline that I will be following for this particular lecture. So, if you just go to this slide, it gives you all the details that we are going to cover in this particular lecture. We are going to discuss about the conventional system of wall formwork. We are going to learn proprietary wall formwork, and in that we are going to learn climbing scaffold, traveling climbing scaffold, automatic climbing scaffold. Subsequently, in the next lecture, we are going to cover various issues pertaining to design of wall formwork, both for conventional as well as for proprietary wall formwork. I will also be giving you some practical examples with help of some photographs that I have collected from different project sites in and around New Delhi. That would be useful for you, right? So, this is how we are going to channelize our today's lecture. So, starting with this conventional wall formwork. Before that, I would just simply define what do we mean by this wall formwork. As you know, the wall formwork are basically the formwork for vertical concreting. So, here we are concerned about the vertical concreting. In foundation also, if you remember, we had done this vertical concreting, but the depth, when you talk of depth of foundation formwork and the wall formwork, they are slightly different. So, in case of foundation, the depth is less, foundation depth is low, whereas in case of wall formwork, the depth is high. So, this is how they are different, but when you talk of the type of concreting, they are essentially the same. You have to perform the vertical concreting. Some of these things we have already discussed, that is why I will go a little faster. When you come to the main components of a wall formwork, you have the sheathing, studs, wales and tie rods and alignment props. Some of these components are common to foundation formwork. Depending on the pressure, the maximum pressure that is exerted by the concrete onto your formwork, the spacing and the cross section of these components vary. If you are dealing with high value of pressure, naturally your sheathing is going to be of larger thicknesses, the supporting studs would be closely spaced, similarly your wales should be closely spaced, tie rods should be closely spaced. So, the spacing and the cross section basically depends on the maximum pressure that is being exerted by the concrete onto your formwork surface. Coming to the conventional wall formwork, sheathing is usually made up of plywood. 1.2 meter is the width, commonly used width, and 2.4 meter is the length. The thicknesses vary between 12 mm to 19 mm. These are the two commonly used thicknesses. When it comes to studs, timber studs are basically of 50 mm by 100 mm dimension. When you talk of wales, they are basically two numbers, 100 mm by 100 mm lumber joined together. You have a gap in between them. The gaps are provided to accommodate the tie rod. So, it would be something like this. So, you have one wale here, another wale here, and in between there is a gap, Now, this gap we use it for putting the tie rod, So, this is how I will show you in the next slide. Now, tie rods are basically made out of some metals. It could be of mild steel, it could be some alloys, mild steel, it could be some alloys. These are commonly used tie rods. And when you finally come to this alignment rod, they could be either made up of timber or they could again be of some metal, having the mechanism of pulling and pushing the shutter. So, is it clear to you, technology class? Is it clear? This we have already discussed. I am just going little faster, because it is a repetition. Okay, clear? Okay. Now, this is how conventional wall formwork looks like. Now, you can see we are talking of this depth, which is slightly larger than your foundation depth. The components, I will just level them. So, this is your just a minute. This is your sheathing. This is your sheathing. Can you read this text, technology class? Can you read this? Okay. So, this is your sheathing, this is your stud, these are wales, and then these are your tie rods, and these are your alignment props. These are your alignment props. These are your alignment props. Fine. Now, we move on to proprietary wall formwork. If you just take a casual search on any of the search engines and just type the keyword wall formwork, you will find there are large number of manufacturers who provide these wall formwork solution. We are not going to discuss all of them. We are going to discuss the three commonly used wall formwork system. One we call it as DOCA. It's basically an Austrian form. Then we are going to see this system manufactured by Perry, and in India we have this common system of L&T formwork. This also we are going to discuss. Now, although the manufacturers have got different systems of wall formwork, there are some components which are very common to most of these systems, and depending on the thicknesses you can utilize those elements, formwork elements, to form these kind of walls. You have a single sided wall, you have a double sided wall, you have a single lift or multiple lift walls, you have walls with vertical or sloping faces. In case of single sided wall, it could be something like this. I have already shown you this sketch. See, this one is the sloping wall, sloping surface. So here is the sloping surface that we are trying to concrete. So the shutter is only on one side. So single sided sloping surface. So suppose you are constructing a dam, it is something like this. So this depth would be very large. So what is done is, normally you cast this wall portion by having shutter only on one side. So this side only you have the shutter or the formwork. So this is how the arrangement is when you have single side wall, inclined, or rather sloping, having sloping surfaces. Then I had given you the example of single sided wall like this. So you have excavated a trench, something like this, and now you are putting shutter on only this side and this side. So you can concrete it here, you can concrete it here. Yes. Can you be little louder, please? What if I don't use? Can you be just speaking near the mic, please? I am just trying to see what you have said. I will just write this. I will just create a new slide. Just give me 1 minute. Now what you are telling is what happens if the slope is very mild. Say for example, there is one situation like this and another situation like this. Are you talking of this? Yeah. When the slope is very high, that means something like this. Okay. In that case, you may have to use bottom shutter also. You may have to use bottom shutter also. I will tell you how it is done. Suppose this is the bottom and this is the top. This area is to be concreted, right? So what you do is you put the bottom shutter. Bottom shutter is kept. Then you put this top shutter also, right? But not in one go. What you do is first you put the top shutter only up to here. You pour the concrete up to here. Then you bring another shutter and you put it here. Then you concrete it here. Like this you do. Like this you do. There is another method also I will tell you. in which what you do is, this is the bottom shutter, top shutter you put in one piece, but this top shutter will have some window at appropriate locations. So, if you are pouring the concrete here, you will be using this window, then you will be using this window, then you will be using this window. Is this clear to you, technology class?
Yeah, actually.
Okay. So, can I go to next slide then?
Sure.
Okay. Fine. So, you now understand what is meant by single-sided wall, double-sided wall, single lift or multiple lift wall. Single lift, normally if you have the height of wall, let us say between 3 meter, let us say between 2 to 3 meter, if you have to do, you can do it in single lift. But suppose you have to cast 10 meter wall, 10 meter wall, so naturally you may not be able to do it in one go. So, maybe you will be doing it up to here, then again another lift, and then third lift. So, this is first lift, second lift, third lift. So, this is what we call it as multiple lifts wall, and this is your single lift wall. So, is this clear? Okay, fine. Now, we also discussed in previous class that there are some components which are common in most of the systems. For example, there is a standardized modular steel panels, strong back member known as soldiers, system of ties. They are all common. The materials may be different, the cross sections may be different, but the purpose is same. In some systems you will find there is additional horizontal veilers. So, depending on the pressure, you may have to use additional horizontal veilers also. I will show you how these veilers, how these soldiers are arranged, and how is this modular steel panel erected. Normally the soldiers, you use it in case of climbing wall formwork. I will tell you what this climbing type formwork is in a few moments now. Now, when you design these proprietary systems, they are designed in such a way that they can be assembled and dismantled very quickly. They are assembled and dismantled very quickly. Otherwise, you may not like to use this proprietary system, because ultimately your aim is to save the labor. Labor is costly, so you are trying to save their time by adopting such a system which requires less time in assembling and less time in dismantling. These proprietary systems can be assembled manually, or you can use cranes for assembling them. Normally for small panels you use this manual assembly, and cranes are used for large area wall formwork. When you have to assemble large area, suppose you have to construct a wall of this much length in one go, then you require crane to assemble such a large panel. Now, I have just drawn one rough sketch to explain you the location of various members that are used in case of wall formwork. So, this is your panel, these are normally made of 2 to 3 mm thicknesses. Thickness is 2 to 3 mm. Now, they are supported by they are supported by Wheeler's horizontal member in some cases, and then you have this member called soldier. So, you have this member as soldier and you have this as Wheeler. In some system you have no Wheeler, only thing that you need to have is this panel, modular panel, and then this soldier, and they are connected with tie rods. They are connected with tie rods. Is this arrangement clear to you, technology class? The Wheeler, the tie rods, the soldier, and the standard modular panel. These are components of patented system or proprietary system. Okay. So, is this clear to you, technology class? Yeah. Okay. Now we see different types of proprietary wall formwork, and one very commonly used type is large area wall formwork. They are also known as gang form. They are also known as gang form. So, either you call them as large area wall form or you call them as gang form. Now, as the name suggests, they are used for forming a large panel so that you can do the concreting of very large area in one go. Now, for manufacturing this, you need a large number of prefabricated panels which are joined together, right, so that they form a large shutter panel, right, so that you can carry out the large area of wall concreting in one go, right. Now, since they are of relatively heavier weight, so they require crane. There are four basic types of panel forms. They are unframed plywood. So, that means you will take straight away one single piece of plywood, connect it with other. There is no frame involved. A frame, you understand? Frame means at its back you have some supporting member. So, the supporting member is not there. This is simply a frame. You take a frame, plywood of 1.2 meter, 1.2 meter by 2.4 meter. That's it. So, we call them as unframed plywood. Then there is a case in which you use plywood in a metal frame. I will show you how it looks like. I will just insert a new slide to show you. Just a minute. Yes. So, I will tell you the different arrangement of those panels. In one case you saw single piece of plywood, you are just going on arranging. So, this is no frame. In another case, you have a frame of metal, so you will have something like this. In between also you have these sections. So, something like this. This is the frame. This is the frame made out of angle section. This is angle section, and here you will have nails. So, with the help of these nails, you are putting this plywood. So, this is your plywood. Is this clear to you, technology class? So, this is the frame in which you have fixed the plywood. This is the frame in which you have metallic frame in which you have fixed the plywood. So, this becomes one full panel. Have you seen this arrangement, technology class? Now, in one arrangement, what they will do is they will make the frame of timber. So, you have this timber frame, and in this timber frame you have nailed the plywood. So, here the nails are there. So, this is the timber frame, and you have this plywood. Have you seen this arrangement, technology class? Are these sketches clear to you? Clear? Okay. So, fine. So, we have seen this unframed plywood in a metal frame, and now I have to tell you all metal will have something like this. So, you have this member here, this is a frame, and then on this frame you will be using another metal sheet. So, this sheet would be of about 3 mm to 5 millimeter, and this angle size would be about 50 mm to 75 mm. In between also you can put some stiffeners. So, this is all metal frame. In earlier case I had used unframed, then I showed you plywood in a metal frame, and this is the example of all metal panels. Now, there is another type which is used for very deep walls, right? They utilize heavier structural steel sections. So, maybe there could be arrangement like this. So you may be using, let's say, some channel section, something like this, and then maybe inside also you have some section. You make a box and then you put the plate here, steel plate. So this can resist very high pressure. These are channel sections. These are channel sections. Here we used angle section. So this is lighter, but using channel section is little heavier. So do you understand all types of panel, basic types of panel? Okay. Now I will show you some example in which you can see there is a large, as you can see, can you see this picture clearly? So here you can see one crane in operation. This is the crane. Tower crane has been used. Tower crane has been used because you can see this is the size of the wall form, this big. So it can handle so much length in one go. Basically you have a sling arrangement through which this crane can come and lift it in one go. Similarly here it can take the whole thing together and it can place it at the next location. This is the example of LNT formwork. LNT formwork. Now this is very similar to Doka formwork. Now you can see there are different components here. What you see in yellow color, is known as H16 beam. H16 beams. Yellow color is visible to you. These things yellow, they are H16 beams. Then what you see here, they are your veilers. And they are alignment props. Here you can see these are your alignment props. Okay. So can you see this photograph clearly, technology class? You can identify different components. I will show you each one of these components separately. Just give me 1 minute. I had shown you this H16 beam. I will show you how it looks like. H16 beam in plan would look something like this. In plan, if you see, it will look something like this. The reason it is known as H16 is because its depth is 16 centimeter, which is 160 millimeter. 160 millimeter. Now this piece is made up of timber. This piece is also made up of timber. And just give me some time. Okay, this is like this. This piece is made up of plywood. Now this H16 beam is made up in a factory. Its weight is very light, roughly about 2.5 kg per running meter, right. It can take a bending moment of 3 kilonewton meter per meter, and shear it can take something of the order of 6 kilonewton. I will give you these properties little later, but the advantage of this H16 beam, you can see it's like this. What has been done is you have removed this much timber from both sides. Okay, you have removed this timber, this side and this side, so it has become light. You have used less timber, but still you have not compromised on strength. No compromise with strength. So this is the advantage. This is the advantage of using H16 beam. There are similar types of product made by different companies. For example, Doka has this component. Perry has got very similar component. We will see all those things in detail, but I just thought of showing you, I mean, the principle and the saving that it results into. Another component I showed you was Whaler. Now Whaler used by L&T is something like this. You have one channel like this, another channel like this, and there is a gap in between. This channel width is 50 mm here, here again 50 millimeter, and this depth is 100. There is a gap of about 50 millimeter in between. This 50 millimeter gap is used for tying the for inserting the tie rod, for inserting the tie rods. Now I will show you the alignment prop. Alignment prop is something like this. In this you have top piece, then you have bottom piece, in between you have some space for alignment, I mean there are threadings. So this is how the props, alignment props are manufactured. This is about 50 NB pipe, 50 NB prop. These are basically hollow. This is a hollow thing. If you see it in section, it would be something like this. So if you cut a cross section here, you will find this. Is this clear to you, technology class? Clear? Okay. Now go back to this photograph again. Now you just try to see the Whaler. Now you can see it is kept in this shape. Okay, the props, it is like this. There are two props, one here and another here. The reason you have in triangular shape is because it adds to the stability. So you understand now why this shape has been given, one prop here, another prop here. The lower prop is of little lesser length. The shape, triangular shape, is essentially to provide stability, so that even in vertical position, if you want to keep them like this, you can keep them in that manner. So, you understand now the various components and their functions. Technology class clear? You can also see the valors are at number of location, one here, another here, here. So, in this sketch you can see, in this photograph you can see 6 layers of valors. So, one here, then another, there are 6 valors placed. Can you guess the height of this wall, technology class? I told you that there are 6 valors. Can you just make a guess of height of this wall? I will tell you how to design these spacing, but just make a guess. Just make a guess. Two meter, 3 meter, 4 meter, 5 meter, 6 meter, 7 meter. Just give a guess. Just make a guess. Anywhere between 5 to 6 meter. So, this wall was cast in a single pour 5 to 6 meter. Because normally these valors are spaced at about 1 meter distance, roughly. Depending on the pressure, the distances, the spacing may vary, but on an average you can expect it is the spacing to be about 1.1, 1.1, 1.2 meter. So, we are talking of the height of wall of the order of 5 to 6 meters in one pour, single lift. So, in single lift this height has been achieved. Okay. Now, we move on to the climbing formwork. Climbing formwork is also known as jump form. Climbing formwork, in some formwork literature you may come across this name also, jump form. So, both are same. Obviously, they are used for high rise structures, multi-storied buildings, where the height of the wall is very high, very large. So, we prefer going in for climbing formwork. Now, in this system you will find that there is a working platform which is supported on the lift of concrete already done. I will show you what does this mean. The working platform is supported on the concrete which you have already cast. Okay. Now these systems are useful where you don't have intermediate floors. Intermediate floors are not available, right? So in the absence of intermediate floors, you will find that it will be difficult and uneconomical to support the wall formwork beyond first few lifts. I will show you with the help of one sketch. Just understand for the time being that in climbing formwork, you are taking the support from the previously cast concrete. There is no need of erecting the formwork or the scaffolding right from the ground. Now I will tell you the distinction between conventional way and the system of climbing formwork. Just see these pictures. Okay. Suppose you have to cast this wall. Okay. You have to cast this wall, right? So you will put shutter on this side, you will put shutter on this side, both sides, double sided shutter. So you have panel, you have soldier, you have veilers, you have alignment props, you have tie rods. All the components are clear. Now in addition to this, you also need to erect this, both side or maybe on one side. What for? Because your worker should be standing here for pouring the concrete. Your worker should be standing here for tying reinforcement for upper floors. They will not be hanging in air. They need some place to sit, they need some place to stand. Right or wrong? Clear? Now when you want to add some more concrete on this, suppose your wall is of very large height, so you need to concrete this portion also. So this is the arrangement for first lift. Now I show you the second lift. This is using conventional wall formwork. Remember, we are right now discussing how things are done traditionally. Now this portion is already over. Now what will be done? You will erect staging or scaffolding either one side or both sides up to this height, and your worker will be standing here to either tie the reinforcement or put the concrete. So this is the arrangement for second lift in conventional wall form, traditional thing. Is it clear to you, technology class? Okay. Now suppose you have to carry out some more portion of wall, so you have to add some more thing. So this is how you will be doing the third lift. This is how you will be doing the third lift. This was lift number 1, this was lift number 2, and now you have made the arrangement for third lift. So what you find is that you are going on increasing the height of scaffolding. Initially it was only up to here, then it was here, then now in this third lift it is up to this height. Now, this type of arrangement may be economical if you are doing a wall of, let us say, 6 to 7 meter height. But imagine a situation in which you have to construct a wall of 40 meter height, 50 meter height. How much money, how much time will be lost in erecting this scaffolding? So, you understand the difficulty, you understand the cost implication, you understand the time implication. So, naturally, for very large height of wall, this arrangement is not preferred. So, people devised climbing formwork. Now, I will tell you the working of a climbing formwork. Now, there are three types of climbing formwork that we are going to discuss: type 1, type 2 and type 3. There are certain differences in these three types. Now, in type 1, what happens is like this: the first lift is done in a conventional manner. No change here. So, whatever I had shown you previously, same thing is here. Any doubt, technology class? No doubt. Now, okay, what we do is, in some situation, for some product, some formwork, you may find that the first lift itself is sufficient, but in some system you may have to do the second lift also in conventional manner itself. I will tell you when do you use only one lift, when do you use two lifts. Now, what we do is, just see this slide. But before this, while I am casting this, I will have one component left inside the concrete itself. One component, I will show it in different color. Okay, it is same color. I will give you the blow up of this component. For the time being, just understand that we are inserting one component at the time of concreting the first lift. Don't worry about what we are inserting. We are inserting some magical thing, okay? It will have some magic later, okay? Now, in second lift, what we do is, we remove this shutter, and at this location we had fixed that particular device. Now, we will suspend our brackets on this device. We will suspend this working platform, or sometimes it is also known as suspended scaffold, from the component which we had left it out in the first lift. Now, on this bracket you will find there is one bracket something like this. This bracket has been fixed in this concrete, and now this bracket will be able to take care of this formwork on both sides, right? Now again, for while doing this second lift, we leave certain devices here, right? I will tell you the details of those devices little later. Just understand the mechanism. Then in third lift, what I do is I dismantle this formwork, use the crane to bring it at the ground level. I clean them at the ground. Then I take this bracket and fix it here at the next location, and once that bracket is fixed, I take this shutter, I will show you in next slide, and then they are fixed there. Is this clear to your technology class? Don't worry what we are fixing, I will tell you those details. Principle is clear to you? Why we are in type 1 climbing formwork, what is done is we are dismantling the formwork, whole formwork, and then we are bringing it to the ground. We are cleaning it at the ground, and then again it is being transported and assembled at the next level. So I think we have to close this lecture now. The other types of formwork, climbing formwork, type 2 and type 3, I will be telling you in next class. So in this lecture, if you remember, we have covered the conventional wall formwork, what are the components, what are the typical cross sections, what are the thicknesses, what are the proprietary wall formworks, what are the different types of panels or frames that is being used. Then we discussed different types of, I gave you 3 types of climbing formwork, although we discussed only type 1 climbing formwork, right? I told you how they are different compared to conventional wall formwork. So if you have any doubt, please feel free to ask. Thank you. And I will be sending you the notes by tomorrow. I am sorry I couldn't send you, I was busy in some other works, but all the lecture notes you will be receiving by tomorrow.
Okay, that's okay.
Thank you and good night. यार चेहरे पे तो फोकस करते ही नहीं है आप, जब